Hello everyone, welcome back to today's session. In this particular session, we are going to deal with what does we mean by vector. Vector and scalar are very important properties to us. In our previous sessions as well, we have seen or used the terminology scalar or vector. At that time, we have just discussed what do we mean by that terminology. But here we are going to see in-depth knowledge about these terminologies, especially vector. So as we have discussed earlier, scalar is a quantity which shows only magnitude, whereas vector is a quantity which shows magnitude as well as direction, right? So physical quantities specified completely by giving a number of units which is known as magnitude and a direction, right? This is very important. It should denote or represent direction of applied force or applied magnitude or applied that quantity. So any physical quantity which are specified completely by giving a number of units, that is magnitude, and a direction are termed as vector quantities. Now, example of vector quantity includes displacement, velocity, position, force, torque, etc. We have already discussed that force is a vector quantity, right? We know that force is a vector quantity just because it has a direction and a magnitude both with itself, right? In the language of mathematics, physical vector quantities are basically represented by mathematical objects called vector, and we can simply add or subtract two vectors. We can even multiply vector by a scalar or by any other vector quantity as well, but we cannot divide a vector. This is very much important, that we cannot divide a vector by a vector, right? We can divide a vector by a scalar quantity, but we cannot divide a vector by any another vector. So this thing should be remembered, that we can add or subtract vector, we can multiply vector, and we can multiply vector with either scalar or any other vector quantity, but we cannot divide vector by another vector. We can only divide vector by scalar quantities. This is important. Now, the operation of division by a vector is basically not defined, right? So it is not defined. Here you can see example that there is a dog which is standing or walking. So let's see how we can define vector using this. So from tail of a vector origin, right? So from tail of this particular dog, vector origin will start. So you can see this is the last point of the tail, and you put dot of your vector arrow just beneath that, right? So here it is starting point, and this will be the end point of the vector, which is to the head of a vector end, right? To the head will be the vector end. So direction of vector is this, and magnitude of vector is this particular thing. So we draw a vector from initial point or origin, that here we used as a tail or a vector, to the end or terminal point called as head of a vector, and we mark it with a arrowhead. Magnitude is the length of vector and is always a positive scalar quantity. Magnitude is length of vector and is always a positive scalar quantity. This should always be remembered, that magnitude will always be a positive scalar quantity, right? So from this particular point we must remember 2 or 3 things, that vector have magnitude and direction, Vectors can be added, vectors can be multiplied, but it cannot be divided. Division of vector is not defined yet. Alright, and we represent vector. Representation of vector is using the arrow, and this arrow can be from starting point, there will be a dot in the arrow, and in the direction it will have a arrow head which will be showing the magnitude of the vector. Now let us define force vector. So what do we mean by the term force vector? The vector quantities that have both magnitude and direction are termed as vector, right? And a force has both. Force have a magnitude and force have a direction, because whether you are applying it in terms of a push or you are applying it in terms of a pull, in both the cases there is a magnitude, that is how much force is applied, and there is a direction, that is in which direction you are applying the given force. So magnitude, force is a vector quantity, and force can be represented using the unit Newton. Now let's take one example here. So this is my dot point, starting point, and there are two forces emerging from this point. One force is F2 and another force is F1. So a resultant force is the single force which represents the vector sum of two or more than two forces, right? So for example, these are F1 and F2. So how we can represent the resultant force over here? So this is the condition which we can use, that is, if we join F1 and F2, it will represent the resultant force occurred or happening due to both the force. In order to add two forces, the start of the second force need to be moved to the end of the first force. So this is important. Start of the second force need to be moved to the end of the first force. So this is how we are going to do it, right? So just remove it another way. So this is start of the second force need to be moved to the end of the first force. So just do it like this. So this will be a resultant force, right? And thus this rule is then extended when considering more forces. If we are considering more forces, we need to incorporate more of it. A force is basically a representation that has both magnitude and direction. We know that, and that's why we are terming it as, or it is termed as, vector quantity. A major feature of force vector is that can be broken into components according to the application of force, and you can also add them to create new vector having more magnitude of all those forces, right? Now come to cross product of two vectors. So basically when we talk about vectors, we do know there is a cross product and there is a dot product. So when we talk about cross or dot, basically both are multiplication operations only. Whether we talk about cross product or we talk about dot product, both are multiplication only, right? So cross product of a vector is result of vector multiplication of vector and is a vector called a cross product. That means when you multiply two vectors, it becomes a cross product. So let us see how it happens. So here you can see, by definition it can be written as cross product of the vector is the result of vector multiplication of vector is a vector, right? So you are multiplying two vectors and getting resultant which is also a vector, right? So that is known as cross product. So let us consider two vectors here. So let A and B be vector in R cube, that is 3 cross 1. So this is R cube form. We define their cross product to be A cross B. This is A cross B. So just define it as A1, A2, A3. B1, B2, B3. So when you will do cross product, the resultant will be A2, B3 minus A3, B2. In the second term, it will come A3, B1 minus A1, B3. And in the third term, it will come A1, B3 minus this A2 and B1. Right, so this is the cross product of a given vector. The cross product of a vector is very useful in definition and in our application purposes as well. Right, so the cross product of vector is used in definitions of defined or derived vectors, physical quantities such as torque or magnitude or force, and even for describing rotations, right? So whether we talk about torque, magnitude of force, or rotation of any object, we use cross product. The vector product of two vectors is a vector perpendicular to them, right? This is the final product which we are obtaining is basically a vector which is perpendicular to them, and its magnitude is obtained by multiplying their magnitude by the sine of the angle between them. So we can even determine the magnitude from this particular thing. So this is basically cross product of a vector. Now let us talk about dot product of a vector. So dot product of a vector is basically a vector multiplication which will give you a scalar quantity. If you multiply two vectors and it give you magnitude or a scalar quantity, then it is termed as dot product. In case of dot product, as you can see here, A and B, A1, A2, B1, B2 are two different vectors. When you multiply them, it will give you A1, B2 plus A2 into B1. So this is basically a scalar product, right, or a scalar value. Now there is some few basic properties associated with dot product. So let's see what it is. First property states that A into B is equivalent to B into A, right? So in case of dot product, multiplication doesn't matter. Whether you multiply A with B or B with A, it will give you the same result. Also, we can move scalar in and out of each of the vector without changing the value. So if we do lambda A into B or A into lambda B, it will again give you the same result. And the third and important one is dot product distributes over addition of vectors. So A into B plus C or A into B plus A into C. Whether you do it like this or you do it like this, it will give you the same result. So this is all about dot product, and I hope the topics which we have covered today is quite clear. Thank you. The last topic of this session is the vector triple product. So what do we mean by vector triple product? Vector triple product, as its name suggests, produces a vector. It is the result of taking cross product of one vector with cross product of two vectors. So here you can see vector triple product can be given as A cross B cross C or A into C, B minus A into B into C. So this is how we obtain a vector triple product, right? So I just hope all the topics which we have covered is now clear. Thank you.